Welcome to the series of videos on hyperbolic functions. Today we shall look at compound angles identity. This is the second videos on identities. We shall look at the compound angles identity for sinh x plus y, cosh x plus y, and tanh x plus y. We are going to translate the knowledge we have in trig identities into hyperbolic identities by the help of the Osborne's rule, which states that the 6 trigonometric ratios used in the trigonometric identities relating general angles may be replaced by their corresponding hyperbolic functions, but the sign of any direct or implied product of two signs must be changed. So anytime we see the product of two signs that are direct or implied, if it is negative, we change it to positive. If it's positive, we change it to what? Negative. So now look at the first one, sinh x plus y. Now let's use the identity in trigonometry, the known identity in trigonometry. We know that sin x plus y in trigonometry is sin x cos y plus sin y cos x. The proof of this identity is in another video. In today's lesson, we are not going to prove why sin x plus y is equal to sin x cos y plus sin y cos x. If you want to find out the proof of this identity, you can search through my videos on the proof of sin x plus y. You have it. Today we are only going to translate these identities into hyperbolic identities. By the Osborne's rule, when we have a direct or implied multiplication of two signs, then we change the sign from negative to what? Positive. If you look at this trig identity that is just written, we don't have any direct or implied multiplication of two signs. So we can straight away translate this into hyperbolic function without altering the expression. So this one becomes sinh x plus y will give us sinh x cosh y plus sinh y cosh x. But we also know that sinh x is defined using the exponential functions as e exponent x minus e exponent negative x all over 2, and cosh x is also defined as e exponent x plus e exponent negative x all over 2. We are going to use this definition to prove this identity. We'll replace the sin x plus y and then sin x cos y, sin y cos x with these exponential functions and see whether we are going to get this. The left hand side will be equal to the right hand side. Good. We know that sin x plus y is equal to sin x cos y, then cos x sin y, as we have seen in the previous slide. The sin x plus y, by the definition in the exponential form, will be e power x plus y minus e power minus x plus y all over 2. Or if you like, we can open this bracket here, so it can be rewritten as e power x plus y minus e power negative x negative y all over 2. Good. So we are now going to replace the exponential functions in these two sides. Then we'll check whether we are going to get the same expression as we have obtained here. The identity we obtained is sinh x cosh y plus cosh x sinh y. So let's pick the left hand side first, and later on we add them. Good. So we are working with the left hand side. Let's do away with this one. So the left hand side can be expressed using the exponential form as e power x minus e power negative x all over 2. That is the sinh x multiplied by cosh y, which will be defined as e power y plus e power negative y all over 2. Let's multiply the numerators. We have e power x minus e power negative x multiplying e power y minus plus e power negative y. So this becomes, this time this will give us e power x plus y. Then this multiplying this same base. So we are going to get e power x plus the negative y, which can be written as x minus y. Then this will take over. This time this will give us minus e power negative x plus y. And this multiplying this will give us minus e power negative x plus negative y, which can just be written as minus x minus y. Good. We know when we multiply the denominator, it will be 4. So the whole expression becomes e power x plus y plus e power x minus y minus e power negative x plus y minus e power negative x negative y all over 4. All over 4. Now let's pick cosh y sinh x cos y, sinh y cos x. So the sinh y will be e power y minus e power negative y all over 2 multiplying e power x plus e power negative x all over 2. Let's work out the numerator. E power y minus e power negative y is multiplying e power x plus e power negative x. So this will multiply this to become e power y plus x, which we can write it as x plus y. Then this times this will give us e power y minus x, which is the same thing as negative x plus y. Then this guy will take over, minus e power negative y times this multiplying this will be power negative y plus x, which can be written as x minus y. And then it will perform its last multiplication, and that will be e power negative y plus negative x, which is the same thing as minus x minus y, all over the denominator, which will be 4. So let's rewrite it and now divide that by 4, plus e minus x plus y minus e s minus y minus e negative x negative y all over 2. Sorry, all over 4. Now we'll bring the two guys together. Let's pick the answer here direct. So I'll just select it and copy it. Let's copy the whole of this. We are going to add them. Remember, the identities says that sinh s cos y plus sinh y cos s. So we are going to add them together. So let's bring these guys here. Good. Then copy the other one. The answer for the other one too. highlight everything and pick it to a fresh page. Good. So we are come to perform addition and see whether we will obtain the expression, the initial expression that we had. Where is that initial expression that we have, sin x plus y? This one. We want to check whether we'll get this expression when we add it. Good. In adding this, the LCM, the denominators are the same. This is 4 and that is also 4. So we only concentrate on the numerator when we are performing the addition. So we'll maintain the 4 at the bottom and then we add the numerator. This and this are the same. So we can just write 2e x plus y, and then this and this, its counterpart is this one, e power x minus y plus negative e power x minus y. They will go off, so they will just cancel this one out. Then when we come here, e power x negative x plus y plus e negative x plus y, this is negative here and this is positive. So when we add that one to, it will drop, so we can just cancel out. Then we have e power negative minus x minus y. Its counterpart is this one, so to give us minus 2e negative x negative y. Good. We can factorize the 2 out, so it becomes 2 into bracket e power x plus y minus e negative x negative y all over 4, and the 4, the 2 will go into the 4 twice, and the expression will be left with e x plus y minus e negative x negative y all over 2. So this indeed is exactly what we obtained here when we threw in, we changed the sin x plus y into the exponential form. Now let's go to the next double angle identity. We have been able to do this one, so we are moving on to the next one, cosh x plus y. Cosh x plus y. We shall use the known identity for the double angle in trigonometry, and with the guide of the Osborne's rule, write an identity for cosh x plus y. So cosh x plus y. What is the known trigonometry identity for compound angle x plus y in cos? Cos x plus y is equal to cos x cos y minus sin x sin y. In applying the Osborne's rule, this is an implied multiplication of two signs, so we have to change the negative to positive if we are to translate this into a hyperbolic identity. So in hyperbolic form, this will be cosh x plus y is equal to cosh x cosh y plus sin x sin y. Similarly, we are going to use the exponential functions and see whether the left hand side will be equal to the right hand side. So let's use the hyperbolic, so the exponential function, to prove this. We know that cosh x plus y, when we want to use the exponential form, it will be e power x plus y plus e power negative x plus y all over 2. We can decide to open the bracket if we so wish. So to be e power x plus y plus e power negative x negative y all over 2. We shall throw in the exponential function for the right hand side and see whether we will obtain this one. So let's pick cosh x, cosh y. Cosh x, cosh y. This becomes e exponent x plus e exponent negative x all over 2 multiplying e exponent y plus e exponent negative y all over 2. We'll concentrate on the top. The top will multiply, so e exponent x plus e exponent negative x will multiply e exponent y plus e exponent negative y all over 4. Let's perform the multiplication for the top. E exponent x times this one will give us e exponent x plus y. E exponent x times e exponent minus y becomes e exponent x minus y. Then this guy will take over, plus e exponent negative x plus y multiplying by multiplying this will have e exponent negative x minus y all over 4. All over 4. Then let's pick the other one, sinh x sinh y. Sinh x sinh y. Okay. By the exponential form, this is e power x minus e power negative x all over 2 multiplying e power y minus e power negative y all over 2. This becomes e power x minus e power negative x in one bracket multiplying e power y minus e power negative y in another bracket all over 4 when you multiply the denominators. Okay, let's now expand the exponent. This becomes e power x plus y. Then when this multiply that, this time this will give us minus e exponent x minus y. Then this guy will take over, minus e exponent negative x plus y, then plus e exponent, this time this will give us plus because negative times negative, minus x minus y all over 4. So we are going to add the two expressions that we have gotten. The cosh x cosh y will be added to the sinh x sinh y. So let's pick the answers that we obtained to a fresh page and then we'll add them together. We are going to perform the addition. So we are adding them. Since the denominator is the same, we are going to maintain the 4. This, and then we add the like terms together. So this plus this will give us 2e exponent x plus y. Then e power x minus y, its like term is minus e x minus y. Since this is positive and this is negative, those two guys will cancel out. The next one, e power negative x plus y, it counterparts this one, e power negative x plus y. Since one is positive and one is negative, they will cancel out. Then we are left with this and that. It will give us positive 2 e power negative x minus y. We can factorize the 2 out and we'll be left with e power x plus y plus e power negative x minus y all over 4. And then the 2 will go into the 4 twice. The expression that will be remaining is x plus y plus e negative x negative y all over 2. And this is exactly what we obtain with the left hand side when we threw in the exponential function. So what we obtain here is exactly what we have here. So it is indeed a proof that when you have cosh x plus y, you can expand it as cosh x cosh y plus sin x sin y. Let's do the last one, the tanh x plus y. In doing this, we'll use the identity for tanh. This is the same thing as sin x plus y over cosh x plus y. Now we know the identity for the numerator, so let's replace that. This becomes sin x cosh y plus sin y cosh s. And we also know the identity for the denominator, which is cosh x cosh y plus sin x sin y. Let's divide through by cosh s cosh y. Divide each item by cosh s cosh y. So let's do that one here. This side becomes sin x cosh y, dividing through by cosh s cosh y. Then sin y cosh x, dividing through by cosh x cosh y, all over cosh x cosh y, dividing cosh x cosh y, plus sin x sin y, all over cosh x cosh y. Let's perform some cancellation where possible. So we have this side, we have cosh y is go off. Then this side we have cosh x also go off. This here, everything will cancel out. Then here there is nothing to cancel. Good. But we know that sin x over cosh x is tan x. So we can write this as tan x. And then sin y over cosh y can also be written as tan y. Then everything cancelled out and the remaining expression is 1. And then sin x over cosh s is tan x. And then cosh y over cosh sin y over cosh y is tan y. So this is also the identity for the double angle identity for tan x plus y. Thank you very much for watching, and don't forget to subscribe to my channel.